The barrier between human thought and digital action is collapsing. For the first time, our minds are becoming a direct interface with the world around us. Sending a text, controlling a drone, or even restoring lost senses are no longer acts of science fiction, they are feats of modern engineering. This is the new reality of brain-computer interfaces, or BCIs, a breakthrough that will end paralysis, unlock new human abilities, and redefine what it means to be human. So, what exactly is a brain-computer interface? Think of it like this. Your brain is the most powerful computer on Earth. A BCI is the ultimate wireless mouse and keyboard for it. It's a direct bridge, a communication highway between your brain's electrical signals and an external device, like a computer or a robotic arm. No hands, no voice, just pure, unadulterated thought. And why does this matter now? Because the dam is breaking. The BCI market is projected to hit nearly $3 billion this year and explode to over $8 billion by 2033. This isn't just a niche medical device anymore, it's the next frontier in gaming, communication, and human potential. But to understand where we're going, we first need to pop the hood and see how this wizardry actually works. All right, let's get technical. Your brain is a symphony of 86 billion neurons, constantly firing tiny electrical pulses. That's you, thinking, feeling, and moving. A BCI is essentially a highly advanced microphone designed to listen to that symphony. However, you might be asking, how do you listen to a thought without getting tangled in all that noise? Well, it comes down to where you place the microphone. There are the non-invasive approach. This is your EEG cap. You wear it on your head, and it reads general brainwave patterns through your skull. It's safe and easy, great for things like simple gaming controllers or wellness apps. But the skull is like a thick wall. The sound gets muffled and you lose all the fine detail. In the case of the invasive approach, this is where it gets intense. Companies like Neuralink place tiny, flexible electrodes, thinner than a human hair, directly into the brain tissue. This requires surgery, but the signal is crystal clear. You can hear every single instrument, every specific neural fire. This is how you get the precision needed to control a cursor pixel by pixel. Once those signals are captured, the real magic begins: AI translation. Machine learning algorithms act as a universal translator. You think, move the mouse up, and your brain fires a specific pattern. The BCI learns that pattern. After some training, the AI knows that when it hears that specific neural cord, it should command the computer to move the mouse up. And the holy grail here is bidirectional BCIs. This isn't just a one-way street of your brain talking to a computer, it's a two-way conversation. The BCI can send information back to your brain, potentially creating sensations of touch for a prosthetic hand, or even feeding visual data directly to the brain's visual cortex. This is the technology that two main players are pioneering. Now, for the main event. In one corner, we have the heavyweight surgeon Neuralink. In the other, the elegant infiltrator, Synchron. Both want to connect your brain to the digital world, but their philosophies are worlds apart. First up, Neuralink. Founded by Elon Musk, their approach is maximum power, maximum data. Their device, the Link, is a coin-sized implant connected to over 1,000 microscopic threads. These threads are inserted into the brain by a surgical robot with stunning precision. Yes, it involves drilling a small hole in the skull. It's the definition of invasive, but the payoff is an unprecedented high-bandwidth connection to your neurons. Think of it as installing a fiber optic internet line directly into your brain. And as of summer 2025, the results are staggering. Their first human patient, Noland Arba, a quadriplegic, is living a life that was unimaginable a year ago. He's not just moving a cursor, he's playing online chess, engaging on social media, and even taking college courses entirely with his mind. He recently scored near perfect on an exam, a testament to how the chip has restored his ability to study and learn independently. Neuralink has already been implanted into 2 more patients, and plans for dozens more this year. And they're not stopping there. Their next project, Blind Sight, is a moonshot, aiming to restore vision by sending camera data to the visual cortex, potentially helping people who have been blind since their birth. Now, for their rival, Synchron. They asked a different question. Can we get inside the brain without opening the skull? Their answer is the stentrode. Picture a stent, that tiny mesh tube doctors use to open up blood vessels. Synchron Stentrode is just that, but it's embedded with electrodes. It's inserted through a small incision in the neck and guided up through a major blood vessel until it rests right next to the brain's motor cortex. No skull joining, no direct contact with brain tissue. It's the ultimate stealth operation, a spy that listens in from the highway of a blood vessel. The recovery is faster, and the procedure is far less daunting. In August 2025, Synchron made headlines with a major partnership. An ALS patient, Mark Jackson, was shown using an iPad running Apple's new native BCI protocol in iOS 19. With only his thoughts, he was scrolling through photos, tapping on apps, and navigating the interface. It was seamless. Synchron is building an ecosystem, integrating with Apple Vision Pro for immersive control, Amazon Alexa for smart homes, and even using NVIDIA's AI chips for faster on-device processing. They've secured FDA clearance for 30-day implants and are rapidly expanding their clinical trials. Neuralink is chasing ultimate performance for complex tasks, while Synchron is building a safer, more accessible platform that could see widespread adoption much faster. And just to stir the pot, a new challenger has appeared, Merge Labs, a stealth startup reportedly funded by OpenAI's Sam Altman, is aiming to combine the best of both worlds. The race is only just beginning. So, what does this mean for people today? For those with severe disabilities, it's not an upgrade, it's a lifeline. Think of patients with ALS, spinal cord injuries, or who are recovering from a stroke. Their minds are sharp, but they're trapped in bodies that no longer respond. BCIs are the key to unlocking those prisons. With Synchron's tech, a user can now command their smart home, like Alexa, turn on the lights, without speaking. They can send a text to a loved one, browse the internet, and regain a piece of the digital world we all take for granted. With Neuralink, Nolan Arbaugh isn't just using a computer, he's reconnecting with his passions and building a future. In another groundbreaking trial from a university team, a woman who lost her ability to speak due to paralysis was able to generate speech through an avatar at 78 words per minute just by thinking the words. Her voice, her identity was given back to her. But this isn't just about restoring what was lost. It's also about enhancement. Imagine pilots flying a squadron of drones simultaneously, or surgeons performing operations with robotic precision guided by thought, or gamers experiencing a level of immersion so deep the controller is their own nervous system. Most importantly, let's address the elephant in the brain. This technology is incredible, but it's also terrifying. We have to ask the hard questions. Your thoughts are your last private sanctuary. What happens when they're data on a server? Under privacy and hacking, you cannot but ask, who owns your neural data? Your doctor, the company? What if a BCI is hacked? Could someone steal your memories, your PIN codes, or worse, engage in mindjacking and control your actions? Then there's inequality. Will BCIs create a new form of human divide, the enhanced versus the naturals? If this technology is expensive, it could widen the gap between the rich and poor on a biological level. And in the case of identity, if an AI is helping you think faster, or a BCI is sending signals back to your brain, where do you end and the machine begin? We are walking a tightrope over the very definition of human identity. These aren't future problems. The debate is happening now. Regulations are slowly catching up, with talks of a UN pact on neuro rights by 2029. Companies like Neuralink are under intense scrutiny for their past animal testing, pushing them towards greater transparency. We must ensure that our ethics evolve as fast as our technology. So, what's next? By 2030, we'll expect fully wireless implants that charge through the skin with thousands more channels of data. We'll see them integrated seamlessly with augmented reality glasses, allowing you to control your digital world with a thought. And with giants like OpenAI entering the field, the pace of innovation is about to go into hyperdrive. Brain-computer interfaces are more than just the next big thing in tech. They represent a fundamental turning point for our species. They hold the promise of healing millions and unlocking potentials we can barely dream of. But they also carry risks that touch the core of our autonomy and privacy. The question is no longer if this will happen, but how we will guide it. Is this the greatest game changer for humanity, or a risky gamble we're not ready for? Let us know in the comments below. Thanks for watching.